Hello everybody, this is Joe, and this is a video about my final project and the pattern recognition class at University of Florida. So what I'm going to show you in this video is about the building a predictor based on some supervised learning algorithm, and using a data set from Amazon to train this predictor to use some reviews from customers on Amazon to predict the opinion of the customer is negative or positive. So let's first see our database. So I found this online, and it's some public data, and it has the data format is just a user ID and a product ID, some score, time, summary, and text. So what we are going to use in this data set is the score here, as well as the summary. So we want to train the classifier with score and summary, and want to do a prediction based on the summary to predict the score is positive or negative. So if smaller than 3 is negative, if larger than 3 is positive. So that's something about the opinion of the customer. And let's start our thing. So what are we going to use in this project? We are going to use NLTK, the natural language toolkit, and also the scikit-learn. So let's talk more about this NLTK. So it's kind of API in Python. So it has many useful helper function like tokenizer or steamer or many other things. But what we are going to use is called tokenizer and steamer. So what is tokenizer used for? The tokenizer is break the sentence into some token, like a word token, individual word. Maybe there's a thing like there is great audio. So it break it into this is great audio. And what is steamer mean? So it's kind of thing that it's get rid of all the redundant of your word. So let's see. We have cookies. When we have cookies, we have cookie, but two of them are the same thing, something about cookie. So in our training data, we don't want to have those many things, that kind of disturbance. So I want to put these cookies and maybe some mirrors to some transfer this word to their string root. So this kind of thing that they do, they put two cookies into cookie. They put manners in manner. So it's kind of a pretty, it's over simple, but I'll bite. So let's see our code. So in our code we load the SQL database from the first code here, and we select only the score and the summary. So first let's print out the head of the message gap, and also this one is about separate our data in training set and testing set, which is very important for our training process and testing with our evaluation of the classifiers. And this one is steamer, very useful thing. So let's set it for okay. This tokenize is function. So I define the function here. So kind of the word tokenize and also and after all this process join, they will join the word into a set, and that's pretty much it. Okay, so we will print out the header, which is raw data. Now the quotas that we processed after the NLTK language, natural language toolkits, and there's other things about how to extract word features. So I will talk it later because only running this code needs some time. So while we run this code, we come on this part which we just talked about. So so we have our classifier, many classifier. So, but those classifier cannot just fit some. We cannot just fit some data or some word into the classifier. We need it to be a list of a fixed length. So how we do this? This thing is called VSM, the vector space model. So what is vector space module? So that's the format way. So it's kind of a list. It's a list with constant length, which just we seek for in your classifier. So how it works? So we have our opinion data. Sky is blue and sand white. So how to put this into this kind of format? So then after maybe we'll cut the stop word like the or is in this sentence and only get the word which has a specific meaning, and like sky blue, sand white. Okay, so we have all these words, sky blue, sand bright. So this is forward. We put forward into a fixed maybe a list of fixed lengths. So there's one vector, a second vector. Oh, that's our readout. So to get rid of it, don't stay. Let's talk about this first. So as we have this, we can put this D1, D2 into this two thing. So the one means the sky blue and sun bright, and all this, it should be a 0. Sorry, it should be a 0. That's a mistake. So the 0, 1, 1, 0 means sky. There's sky blue and sun bright. The sky blue and sun bright. The other ones are empty. And so that's how we put our data into our training set. And we generate it because we need to generate a dictionary. So let's see from the top of our running result. That's it. Okay. So this one is what we call the raw data. It's not being precise. And I print out the first one of the training sample. So because there is we shuffle or put the order of the data into some randomly. So it's not exactly the first data we got in here, in the raw data here. So it's the first data of training data is still continuous. There's only 3 words, and and this one is the what we call the list of here. We call the list of space vector module. Where is it? Oh, sorry. So this one. So why this one has 3 elements, right? Why there's 5 elements? Because we use a second dimensional thing order for it. So that's almond, grid by, almond, the grid and by, which is the first 3 here. But in order to get avoid of some disturbance, like there will be So it will be like, is this him or this is him? So these two things, they are different. But they are with the same word. So if we just put the specific term module into 3 words, into as many as word that the sentence has, so there's maybe some confusions in the situation, like either is this him or this is him. So what we are going to solve this problem is to put the thing into couples. So we have our album grade and also grade by switch plus to the 3 word in the header. There's 5 thing. So that's it. So there's our specific value. And another thing that this TF-IDF, what's the meaning of it? So it's kind of generates out the term. The TF means the term frequency, and IDF means inverse direction frequency. So it's kind of plus those 2 things together, and so we have our let's see we have maybe some useless word like me or the or things like that. So those words happens very frequent into all the dictionary, like all the elements, all the piece of data. Maybe every piece of data has them, like or this, things like that. Okay, but those kind of word is useless in our prediction. So it don't generate any specific information for us. So we want to get rid of it. We count the frequency of the term in the whole dictionary plus it with the term of frequency in each specific term. So the word that happens more in a specific term is very useful. The word happens very generally, frequency is frequent. It's not useful. So how are those weight? So it kind of reduce or increase the weight of the our element here or feature here. Use those data. So that's our precise of the whole data set. And after this, I will talk about more about how to fit this data into our classifiers. So we see you next time. Bye.